Welcome back. So in this video, we're going to graph how to solve, we're going to solve by graphing nonlinear systems. So you do have something up here that says there is no general method for solving systems of nonlinear equations. Sometimes substitution is best, other times elimination is best. And that's what we're going to spend the majority of the lesson is using these two methods here. It goes on to say if the system contains two variables and if the equation of the system is easy to graph, then graph them. By graphing each equation of the system, you can get an idea of how many solutions a system has and approximate their location. So example 1, graph each equation of the system. Solve the system to find the points of intersection. So first we have a line. So negative x plus y equals 2. Let's put this on our y equals mx plus b. So I'm going to add my y or my x over, and I have y equals x plus 2. So going from here, I know my slope is 1 or 1 over 1, and I know my y-intercept is at 0, 2. So let's graph. We've got 0, 2, and then my slope of 1 over 1. I'm going to go the entire graph here. When you're doing this in my math lab, right, it makes it accurate for you. But when you are doing this by hand, you have to make sure your graph is accurate. Otherwise, it's not really useful graphing at all. So I'm going to use my rise over run 1 over 1 throughout the entire thing, and then draw a line through here. All right, so there's my line. My next one of a circle. This actually tells me everything I need. This tells me the center is at 0, 0 because it's x squared, y squared. And then I know that my radius is 2 because the square root of 4 is 2. So I will start here in the middle, and then I will go up 2, down 2, right 2, left 2. And as you may have noticed, because my line is accurate, when I go up 2 and left 2, those are points on my graph. So let's go pink. So this point and this point are my two solutions. So it looks like my two solutions are negative 2, 0 and 0, 2. Okay, let's go again with my parabola. So this is your most basic parabola shape, y equals x squared. That starts at the origin, and then plug in some numbers. 1 squared is 1, 2 squared is 4, and 3 squared is 9. And then that's going to mirror each other. So not a lot to do on that. My hyperbola, though, we do need to do some work on this. To have this in standard form, I need this to equal 1. So we're going to divide everything by 4. So this is x squared over 4 minus y squared over 4 equals 1. This tells me a squared is 4, so a is plus or minus 2. My b squared is the same. Okay, and I don't really need to worry about the foci. That's not going to help me with knowing where these intersect. And then lastly from this, I know that the center is at 0, 0, because again, it's x squared, y squared. So your h and your k are 0. So I will plot that. The center is at 0, 0, but that's not really part of my parabola, right? So it's not an intersection point. My A is 2, so this is my vertex. And by the way, I know that it opens up this way and this way because it starts with that X. Okay. So then it goes down 2 and over 2. This is how I make my box. Okay, that box then gives me my asymptotes, which go perfectly diagonally through this in both ways, since your A and your B are the same. And then all of that to finally be able to draw my hyperbola, and I'll do it in black. So all of this red is not really part of my graph, right? Only these points right here. And so my hyperbola is that shape right there in black. So I have my hyperbola, or sorry, my parabola, and then my hyperbola. So you can see that these two never touch. This is this right here. So my answer is no solution. Okay, so those are some examples of graphing. My math lab is going to ask you to solve some of these by graphing.